Okay, and this is on solving right triangles. We actually did a little bit of this in chapter 1. And we'll spend this whole chapter on right triangles. Later we'll get to what they call oblique triangles, and those don't have a right angle. First, in this chapter, when you see the phrase to solve or just solve, means find all the missing parts. That means all the missing sides, all the missing angles. So if they just say to solve or solve, find all the missing parts. Remember, in Trig, if they use the capital letters or uppercase letters, okay, those use capital letters for angles. Okay, and your right angle is always going to be your angle C. Okay, if they're using A, B, C. Okay, and the lowercase letters for the sides. And if they use A, B, C, C is always the hypotenuse, the side opposite the right angle. So the lowercase c is always the hypotenuse. And those we've already talked about before. Okay. The main steps that you use to find the sides and the angles of right triangles. Okay, and almost always in Trig, a picture is going to help. So draw a picture, draw a sketch, draw a picture. And draw it big enough that you can, see what you're labeling. Okay. Second step, label the given. And that's usually what I keep on my picture, is what was given. The third step, represent the quantities to be found. And my hint on this part, because you can use all 6 trig definitions, you can use the Pythagorean theorem. I always try to put the unknown in the numerator. That just saves you keystrokes on the calculator. Okay, and you should all have your 1-9 calculator notes in your notebook still. We've been away from the calculator for a chapter, so as far as actually doing these. So if you need to go back and review, how do you punch that in on the calculator? You actually have that in your notes. The fourth step, write the equation, and that's using your definitions, like sine is opposite over hypotenuse. And if you need to write out the opposite over hypotenuse, go ahead. If you're past that stage and you're okay to do it without writing out the words, that's fine. Solve and check. The solve and check would be, go ahead and solve it, and then number 1, I would check how many degrees in a right triangle? How many degrees in any triangle? 180. Okay, so if it's a right triangle, your 2 angles ought to add up to 90. Okay, or close to it. Okay, and then Pythagorean theorem should also work. Okay, as a check. Okay. Okay, so we're going to use Pythagorean theorem. Good old Pythagoras. Okay, and that's in a squared plus b squared equals c squared. if they put it on a coordinate plane, then they might be using x squared plus y squared equals r squared, and r is the radius vector. That's the same as the hypotenuse, okay? And the 6 trig definitions. Okay, now when you're solving right triangles, here's another thing to star. Okay, always use the given to solve for the unknowns. Always use the given to solve for the unknowns. Okay, don't use something you solve for to solve for something else. And the reason is because of the rounding, and it could cause a chain error. If you made the mistake in solving for the first answer, it would carry all the way through the problem. So you always want to go back and use the given to solve for something. Okay? Now, the important part in this section that's different from what we did before is on page 114. There's a little table, how to round your answers. Now in the book, the author is using significant digits. Okay? When we get to the test, I'm not going to use significant digits. I'm going to use round to the nearest tenth, round to the nearest hundredth, round to the nearest whole unit. But to be able to check answers in the book and to get used to significant digits a little bit, okay? If you look, they have a little table. We're going to go ahead and put it in the notes. So you can either look in your notes or you look in your book. If your angles are to the nearest degree, okay, if your angles are to the nearest degree, if you've got a right triangle and they label one angle as 23 degrees, okay, then your sides, you're going to round to 2 significant digits, and we're going to talk about significant digits in a minute. If your angles are to the nearest tenth of a degree, so like if I gave you an angle 47.9, okay, then you're going to round to 3 significant digits. So it's nearest tenth of a degree or nearest 10 minutes. So if I gave you an angle like 28 degrees, 50 minutes, then you know the sides have to have 3 significant digits when you round them. If your angles are to the nearest hundredth of a degree or nearest minute, so like if I said an angle was 15 degrees, 17 minutes, then we're going to go 4 significant digits on the sides. Okay? And vice versa. If my sides were all 3 significant digits, then I know I need to get my angle to the nearest tenth or the nearest 10 minutes. Okay? And I will tell you, going through this book more than once, that we have found even the author did not follow his own rounding. Okay, so but that's when you look at the back and you solve the answer exactly, and then you look in the back of the book and it's like my answer was 9.6 and the author's answer was 10. Why? It's all in the rounding. The author rounded to 1 significant digit, okay, or 2 significant digits. Okay, so now significant digits. definition, okay, for this author, significant digits. How many of you had chemistry already? Already talked about significant digits? Oh, okay, significant digits. Definition-wise, it's any non-zero digit. Any non-zero digit. So anything other than a zero is considered significant. Or any zero which has a purpose any zero which has a purpose other than placing the decimal point. Okay. So, to give you some examples, if I gave you 0.00304, okay, the ones that are significant, okay, are the non-zeros. I will tell you any zero between two non-zeros is always significant. These two zeros I need to place that decimal point, because if I don't have these, that changes the answer. Okay, so this has 3 significant digits. Okay, you might want to highlight them or underline them. Okay, if I had like 29.40, any non-zero is significant. This is significant. This is. Do I need this 0 for the decimal point? No. That means it has a purpose. That means there was something over here in the rounding, okay, that one is important. Okay? It has a significance other than placing the decimal point, because I don't need it to place the decimal point. Okay? So that one counts. Let's say 301,450. Okay, this is significant. Any zero between two non-zeros is significant. The 4 and the 5 are non-zero, they're significant. I need this 0 to get the decimal point. If I don't have that 0 on there, it changes the value, right? Okay, so that one has 5 significant digits. Okay, so the basic thing is when you get done with your answer, or as you're working the problem, you've got to look at what's given. Like if in the problem they round everything, like if they give you angles to the nearest degree, then you know your answer is going to be 2 significant digits. If they give you angles to the nearest tenth or nearest 10 minutes, you've got to round your answers to 3 significant digits. Okay, and this will get better with practice. I will tell you the reason I don't do that on the test. Basically, I've been in more than one Trig book, more than one calc book, more than one science book, and they don't all necessarily agree. So as long as I say round to the nearest tenth, you're going to know 1 digit. Round to the nearest hundredth, you're going to know round it to 2 digits. Okay, but you have to do this as far as looking in the back of the book, or as we check them, what the answers are. Okay, I want to go through 2 examples. Okay. Okay, and it will just say up at the top, it's just going to say solve. Okay, keyword solve says find all the missing parts. Okay, it's triangle, use uppercase ABC, triangle ABC, if, okay, side A, use a lowercase a, is 25 centimeters, angle B is 42 degrees, and angle C is 90 degrees. Okay, and I'm going to draw a picture. The right triangle. Okay, I'm labeling this one A. Doesn't matter as long as you label your angle B is 42. The only part that I put on my picture is the given. My angle C is 90, and side A. Remember, the side A is opposite angle A, so this would be side A is 25 centimeters. Okay. Now, right off you can solve for angle A, right? Angle A is 90 minus the 42, right? 48, you agree? So angle A is 48. Now, I do not want to use angle A to solve for anything else. Because if I made a subtraction error there, it's going to go chain all the way through. Okay? In terms of what's given, okay? In terms of what's given, let's say, how can I solve for side B? In terms of this angle, B would be the opposite, and A would be the adjacent. What trig function? Tangent. Okay, so tangent of angle B is opposite over the adjacent. Now, if you're at that stage where you don't need to write that down, that's fine. Okay, tangent of 42 equals B. Notice I'm trying to put the unknown up in the numerator. 42 over 25. Okay. Now in your calculator, first make sure you're in the right mode. You always want to check mode on these. So check the mode and go to degrees. And you might want to go to 4 decimal places, and then we'll adjust. So on this one, tangent of 42. Okay. Now this part I do want you to write down. Okay. The calculator rounds it to 0.9004 equals B over 25. Now, I read that B over 25. Really, I should read it B divided by 25. What's the inverse of division? Multiply. Multiply by 25. Now, you don't have to show this because you're going to do it on the calculator. Okay? So what you're really doing is multiplying by 25 on both sides. So take what's on the calculator times 25. Okay? And I get 22.51. Okay, now, my angles that they were given, nearest degree. How many significant digits do I need? 2. If you go back up, you need 2 significant digits. So you got to go back to this and say I need to round this to 2 significant digits. So that's 5 or greater. So I need to round that up to 23. Okay. So B is 23. Okay, what else do I need? I need the hypotenuse. Now, do not use that B or the 48 to solve for anything else. You use what's on your picture. Use the given. In terms of this angle, this would be the hypotenuse. I want to put it up on top. The hypotenuse over the adjacent. What trig function? Hypotenuse over adjacent. What is it? Secant, right? Secant. Secant of 42 equals the hypotenuse over the adjacent. So secant of 42, the hypotenuse is C, the adjacent is 25. Okay, now you got to go back on your calculator. Secant of 42. Okay, so I want to do secant's a reciprocal with cosine. So I do cosine of 42, and then I can do the reciprocal of that. Okay, and I should get 1.3456. Now, you can go back on your calculator and do it in one step. If you do cosine of 42, do I close the parentheses and do the x to the negative 1? Must have to. So do cosine of 42 close the parentheses, and then the x to the negative 1. Should get the same answer, 1.3456 equals c divided by 25. Okay, now solve for c. Do the inverse, multiply by 25 on both sides. So times 25. Okay, and I get c equals 33.6 or 0.64. And they want two significant digits, so that means you need to round this up to 34. Okay. So now check. Do we have all the missing parts? We've got all the angles, all the sides. Yep, and everything's rounded. Okay. Any questions on that one? Okay, let's do one more example. And they will just say solve triangle ABC if angle C equals 90, side B is 8.15, and that's in meters. Side A is 3.78, and that's in meters. Okay. Okay, draw a picture. I'm going to label my A down here, B. Okay, they gave us side B. Remember, side B is opposite angle B, so this is 8.15. Side A is opposite angle A, so this is 3.78. How can I solve for the hypotenuse? Yeah, Pythagorean, A squared plus B squared equals C squared. So we'd have our A is 3.78 squared. Should be able to just punch this right in on the calculator. Okay, so 3.78 squared plus 8.15 squared. Okay, I get 80.7109. Notice it's storing all the rest of that. Okay, and that's C squared. Now to get rid of that square, you got to take the square root of both sides. So you do the square root and do second function answer. Remember, that's above the negative. Second function answer. Okay, and I get 8.9839 equals C. Now, if these sides are three significant digits, then this needs to go to three significant digits. So we've got 1, 2, 3. You look at this one, it's not 5 or greater, so you round it to 8.98, and that would also be in meters, and that's C. Okay. Okay, then on the angles, I will tell you when you're solving for angles on these right triangles, and part of this is for later on when we do the oblique triangles, you always want to solve for the smallest angle first. So which is smaller, A or B? A, because it's opposite the smallest side. Okay, so in terms of this angle, this would be opposite and this would be adjacent. So tangent of angle A is opposite over adjacent. Right, right. And you want to, I said it, we didn't write it down. Solve for the smallest angle first. And it's opposite the smallest side. Okay, so you might want to make a note out of the side. Solve for the smallest angle first. It's opposite the smallest side. So we'd have tangent of angle A. Opposite would be 3.78. Adjacent would be 8.15. Now just read that. 3.78 divided by, it's telling you what to do, divided by 8.15. Okay, so I get tangent of A is 0.4638. Okay, now you know the value of the function. You know the value of the function. What you don't know is the angle. That's when you do inverse tangent. So you do inverse tangent of that answer. So do second function answer. Okay, and I get 24 Now, when you do that, the tan is gone. So your angle A is 24.8820. Now go back up. If we are at 3 significant digits, we want to go to the nearest tenth of a degree, or nearest 10 minutes. We're going to go nearest tenth of a degree. So this would be nearest tenth. You look at this and round this up. So it's 5 or greater. So 24.9 degrees. 24.9. You agree with that? Okay. Now, it's real tempting there to just subtract and say 90 minus 24.9. But what if 24.9 is wrong? Okay. So you go back and use the given. If I want to solve for angle B, okay, I can still do tangent. Tangent of angle B is opposite over adjacent. So tangent of angle B, the opposite, okay, opposite would be 8.15. The adjacent side touching angle B is 3.78. So it's telling you what to do. Take 8.15 divided by 3.78. Okay, and I get tangent of B is 2.1561. You know the value of the function, you don't know the angle, so that's when you do inverse tangent of that answer. Now, what you don't want to do is you don't want to just type in this. Why? Because you're not seeing all those other decimals. Okay, so you want to do second function answer, because that's got it all in there. Okay, and now it's angle B, and they want it to the nearest 3 significant digits, so 65 point, it was 0.11, okay, so we want to go 65.1. That's not 5 or greater, so you're going to leave that the same. Okay, then you should be able to check if I take the 65, you know, if I add these two together, am I going to get 90? Yeah. Okay. That ought to be your check. Okay. So always use the given to solve. Don't use what you solve for. Okay. Okay.